So today we have Satya Mantha. He's a key architect over at Fission Labs. Fission Labs is a leading AI services company. I know them very well. I used to work there many years ago. And, one of the things that I've seen a lot of talk about is this whole idea of forward deployed engineers. And I've seen that some of the big model companies are doing a lot more in terms of partnering with services companies, going as far as I think I saw Anthropic actually partnered with some PE company to actually set up a services company. So I thought maybe it would be an interesting thing to discuss today is this maybe start off with this whole concept of forward deployed engineers. And certainly a lot of buzz about it. And when I heard that term, a year ago or whatever, it kind of harkened back to the days of when I worked in the services industries, and there, forward deployed engineers were called on-site engineers. And is there really any difference between a forward deployed engineer, on-site engineer? Why are they big again today in the context of AI, et cetera? So maybe kick it over to you first, Satya, and see
Yeah.
what you think.
Yeah. Thanks for having me, Sunil, on this podcast. It's really great to meet you all again. In order to really understand the concept of forward deployed engineer and all, it actually, let's take a backdrop towards history also. And this particular term was actually coined by Palantir in 2010s or so. And they had a very important challenge with respect to implementation of their products as such, right? They were primarily working for government agencies and military organizations or so. And one of the key challenges there is like their data, the government data sets, and they had very strict compliance and regulatory needs. So the products could not be directly sold out to them, and there were differences between the data sets as such to implement. So they started developing teams of people, on-site folks, as what you said, and they deployed it within those environments. Now, during those times, the engineers used to learn about the data sets, to learn about classified systems. They used to bridge the gap between the uh, product versus the actual implementation needs of it, creating data pipelines, working on implementing the product as such and all. And this was more of a field engineering kind of a thing, if you look at it, right? Then later on, how they started establishing is they started learning the patterns at the client ends wherever they were developing, and they started putting that into the product. This created a continuous loop for them to constantly evolve the products as such and do deployment engineering. Thereafter, when I started researching about forward deployed engineering more, I found out that they had a very peculiar setup also. And the setup was related to the organizational units they tried to form. They essentially formed two types of units. One is called as Echo team, and another is the Delta team. The Echo team was primarily comprised of the domain experts who were constantly looking at the implementation domain of the product as such, and then trying to understand where are the high potential use cases are for customer value. And the engineering team sitting there would go ahead and implement solutions on top of it. Thereafter, the engineering team was the Delta team, essentially, which was very high-paced engineering team. They used to develop the custom solutions on top of the products they were trying to implement. The learnings from them were later then transferred into the actual core product team, where they would architect it for scale and then create an out-of-the-box product. So that's the kind of a history, and this term slowly became what we call as forward deployed engineers because they are really working at customer space as such, right? So
So
that's
that
where
would,
the things went into. Yeah.
since you have a background also in services, what do you think?
Yeah, I think there's one unique difference, and that is you're still trying to advance your product. So these forward deployed engineers, they have access to the code base, the product code base, and they're enhancing the product at a very high velocity in the context of the customer problem that they're trying to solve for. And and they're empowered to make those changes as rapidly as they can to create a good fit for the customer. So, and one challenge with that, of course, one downside to that is you have multiple forward deployed engineers working with different customers. They're accelerating the adoption by customizing the product for that particular customer. And then you may end up with a lot of technical debt that you have to resolve in the back end because you might end up with changes to the code base that may not be compatible with each other. So there is a challenge. So it still requires some. So you really need senior, mature people. It's not just that you deploy some engineer there, but these are people with a product vision. These are people who understand the product and they're product owners in some sense. They bring consulting skills. Uh, they are hands-on engineers as compared to pure on-site coordinators who do reporting and management and orchestration. But these are people who actually write code, who understand the product. They're pretty skilled. So there are these nuances. I just thought we should just call that out compared to the traditional consulting on-site engineer role.
Sam, you look like you're dying to say something.
No, I actually, to be honest, my initial years was in the HP Research Labs, and then later I did a few startups, and then I went on to become the head of professional services for Americas, actually, in my previous company, and I was basically leading the effort. I was coordinating with various clients. Also talking to customers, the C-suite, and then also I was trying to bridge the gap between the CTO office, pre-sales, etc. So one of the things I found out the most interesting about it is the evolution that has happened, especially in the latter phases of my engagement, actually, where I saw the AI industry was heavily moving into models like larger models, smarter models, faster models, multi-models, modality models, etc. So what really we are seeing is there are many challenges in this space. This is typically not the same challenges we already faced in professional services when we build huge data centers for customers. The real challenge is the deployment, the orchestration, the governance, the observability, the scalability, and also the infrastructure integration and operational reliability, right? So now the question becomes, what is a forward deployment engineer, right? A forward deployment engineer is a hybrid role which has emerged, as Satya was putting it very recently. It includes software engineering, systems engineering, infrastructure expertise, architecture, custom integration, all these things put together. So then you'd start asking me a question, actually. Unlike traditional software engineers, what do FDEs do, right? They deploy systems directly into production. They solve infrastructure problems. They integrate with the customer ecosystem. They automate workflows. They also optimize deployments and often bridge product engineering with custom operations. So it is basically different things, but the main thing is why FDEs matter more right now is because modern AI systems are distributed. They're infrastructure heavy, GPU intensive, network intensive, and operationally complex. So the challenge is no longer, can the model work? No. Sajaz has told it so many times, and that's what he's been struggling with. Can it scale? Can it integrate? Can it be governed? Can it operate reliably? Can it fit into the enterprise workflows? Can it run cost effectively? So there are many, many points you are looking at this point to effectively say, how do I do that, right? So enterprises underestimate infrastructure complexity, deployment effort, data quality challenges, governance requirements, operational costs, and so all these AI projects fall into fall after the demo phase. And Satya can validate it. How many of them are in demo phases?
I want to go back. So all the challenges that you guys have talked about, I've heard those same challenges when we were talking about big data and ETL pipelines and stuff like that.
Yep.
So what's new about AI that's caused this term to become popular again? Or is it just kind of rebranding of something that's always been there?
I can speak to that. I think when people started talking about big data, it was early 2012, 2013, in that time frame. And I was in a consulting company at that point in time and engaged with multiple different customers across different industry sectors. And it was, I mean, a lot of people called it POC hell, right? For close to 4 or 5 years. Not just us, many of our peer group companies and even product companies, they're all put through what is called, POC hell, because everybody was kicking the tires. Every customer was trying it out, building some POCs, validating the ideas, and then they would go out to seek funding for production deployment. So, and along the way, there were questions on security, compliance, data residency, compliance with data laws. So it took a while before that industry actually took off. So in some sense, I'm happy that the industry is beginning to acknowledge the role of the FDE, which in the past, SIs used to play that role on behalf of product companies trying to build and deploy solutions within IT organizations at scale. So, in some sense, I would say that the product companies have now stepped up. They recognize the importance of this role, and they're trying to short circuit or reduce the cycle time before you can go to production. Otherwise, you'd spend 4 or 5 years in production hell, they would call. And how do you really cut that cycle short? So that's one, I think, insight that I just learned, having gone through this before, and now seeing what others are doing in the uh, AI product industry. Yeah.
Yeah.
What do you think,
I
Satya?
think I would echo with Sajad on this one and what you mentioned, Sunil. So, with my background, I'm coming from also an ERP implementation and product company background as well. Now, the similar pattern is actually applied there as well. If you look at it, ERP companies like Microsoft, SAPs, and all, they would build the core of the product, right? And then you have product engineers or system engineers or SIs as well. We were an ISV at one point in time where we used to build product on top of the core Microsoft ecosystem as such. And then we had implementation teams and all, and the consultants who used to go and implement it at specific customer places. Now that creates a layers of software product, and it increases the complexity of deployment and implementation at the customer spaces with their specific needs and changes. So in my view, the concept still of forward deployment engineer is stemming out from all these various experiences and all. Coming to the world of AI, right now, as what Sam already mentioned, there are new challenges coming up. Things like we are moving from implementations of system of records to something like building system of intelligence, right? And when we try to build system of intelligence, we are talking about LLMs which hallucinate. How do you do context engineering within the picture of the client data sets as such, how you build new knowledge bases, what are the different vector stores that you might have to utilize, what are the different hyperparameters for evaluation, what are the pipelines you need to look for building up the rack pipelines as such with these parameters, and then evaluate whether the model is hallucinating or it is grounded to the actual core knowledge base of the institution where there is being deployed. So these concerns become very valid because the foundation model companies, they can release benchmarks which are working on open data sets, global data sets, and then they can claim that, okay, we have 80%, 90% accuracy on coding or any other subsystems. But what happens when this model is implemented with my data in my organization for my business processes, how it will actually behave? And that's why we require these skill sets and these forward and deployed engineers who could help.
Yeah, I think you couldn't have said it better. I fully agree with you. I think a lot of these models have been trained with internet data, but
Yes,
when they meet enterprise data, their behaviors can't be predicted. So you should expect surprises there. And
absolutely.
that's one of the reasons why you need forward deployed engineers to actually adapt the product to the customer's needs. And not a lot of the customer stack is going away anytime soon. You're simply adding to the existing technical estate out there. So you have layers and layers of a lot of legacy technologies. And now you have this new technology. It needs to fit in, it needs to work with, and needs to integrate and infer with the data and the data systems they have. So the complexity is not going away anytime quickly.
Absolutely.
So you guys, I think I've answered my other question is why are these big LLM companies, working with SI partners and actually setting up SI
In fact, there's some of them are opening up their own
yeah,
professional services
yeah,
organizations,
like
right?
Anthropic, right? And
Yeah,
so
we heard from Anthropic. I think we also have seen some press on OpenAI.
OpenAI with the
Yeah,
deployment company as
yeah,
such.
they're trying to build consulting and McKinsey-like and engineering, for deployed engineering organizations that combine all of these roles with this business consulting, technology advisory, including actual engineering and hands-on integration work. So they're trying to do those kinds of things. I guess it's probably because they would see these actions as a means of accelerating product deployment. So, and helping the customer reach their goals much faster. So that's really what I would expect these to be. And also the surface area, I mean, compared to just an ERP deployment or compared to, another application deployment, we're now talking about AI and its abilities as that offer such a large cognitive surface.
Surface.
Now you're taking such a large cognitive surface and trying to make it work in a narrow, defined problem domain. So,
sorry,
and
I
that,
don't understand that, Sajjad. You said take it a big cognitive surface and apply it to a narrow domain.
yeah,
I
let's say
don't understand what you mean.
you take a frontier model,
Yeah,
its capability surface is so vast,
yeah, it can do a lot.
it can do a lot. But now, when you are working in an enterprise, you're applying it to one business process. You're trying to apply it to one operational domain in a very narrow domain. Now, the question is, you don't know how the model would behave in such a narrow domain. First of all, the model's been trained largely on internet data, not so much on, you know, um,
Private data.
enterprise data that's proprietary to a given enterprise, which makes it even more specialized. And their business processes, their workflows are even more specialized and even more unique. So the level of uniqueness just goes up so much. And now you have a much more generic, general trained LLM or frontier model, and you're trying to make it work in that given narrow domain, in that given narrow space. So, and nobody knows how it would behave. So you really need the last mile adaptation work to be done. And people who are empowered to understand what's needed by the customer and who can make product level changes if required to actually make it fit in that given domain. So I think that's a unique skill that is beginning to emerge as as a much wanted skill.
Actually, are you
Satya,
talking about supervised fine tuning? Because basically you're saying that the models have been trained on generic
It's not
internet
just
data.
model, right? I mean, there are also
Fine
different
tuning.
aspects, right?
Yeah,
You have RAG capabilities, you have increasingly graph RAG, you have security.
correct.
So there's so much more adaptation that needs to be done.
Yeah.
Um, And then, of course, data locality. Even with big data, it was not easy to get a data lake established to serve. Even a data lake offered a pretty vast surface. It was more a platform than a point application, right? You could serve multiple use cases having established a data lake, right? So again, the impact domain was quite wide. And who would fund it, right? So the people who would fund it are people who have a point business problem. Now you're trying to solve a point business problem, and to solve that point business problem, you're deploying this big estate, which can actually serve others. So then the natural question is economics, right? If I'm a process owner, the natural question to ask is why should I invest in such a large estate when my needs are so narrow and so specialized, right? So can those costs be amortized across other lines of businesses and other people? So I'm reasonably certain those are the kinds of questions you'll have to deal with as you're deploying AI, because while the deployment upfront cost might be high, you might have to build a GPU farm, you might have to build these pipelines, and you might have to connect with these data lakes, build security, do a lot of upfront work to solving one point use case. Then the argument is, can those costs be amortized across other business processes, other teams, other departments? Can everyone pay their fair share? Or is this a centrally funded initiative that will benefit all? So you certainly would need consulting skills, advisory skills, somebody who can do cost benefit analysis. So I think that is par for the course now as you look at deploying these kinds of instances. Yeah.
So one question that kind of that triggers in my mind, I'd like to ask Satya this, is that these four deployed engineers, how long do they stay engaged with the customer? Is it like they just come in at the beginning of the project, help architect, and then they jump out, or are they involved throughout the project? What's been
Yes.
your experience?
It is a continuous process, in my opinion. It's like you have to still, once you deploy the solutions, you have to see sustenance as well, right? And then you have to go back and look at the solutions implemented as well and continuously improve them. Because when you are really talking in context of AI models and all, there would be some progressive degradation also, which would be coming in because the context is continuously changing, right? Your knowledge is also developing and changing across. That's where, when we talk about, and what Sajjad rightfully mentioned, it's not only that because we are dealing with a stochastic system, we need to make sure that the context engineering part of it is also handled. And that can only happen within the customer boundaries, if you look at it. And that context engineering involves plethora of activities, and that would be coming in from data engineering related activities, as we were talking about data lakes and all, because primary source of knowledge is the data lakes of the world, which are driving these organizations. Then you have to go and make sure that the context which is fed to the LLM for the final output which you are getting in is also evaluated, uh, continuously monitored for accuracy, groundedness, etc. Right? So that's very important for this to be considered. So in my opinion, in a nutshell, it's a continuous activity as you go along. That's where there is a lot of value in this space.
I think the main thing Satya is saying is, for example, in the traditional sense, we had a traditional deployment engine, but the real deployment problems today are different, right? Kubernetes integration issues, GPU driver problems, network bottlenecks, storage performance issues, like we have struggled with that. Model serving optimization. You have again things like inference scaling, right? How do you do that? Then multi-cloud integration, like you could do AWS, you could do Azure, and identity integration. This is like compliance restriction, deployment automation. We can go on and on. The thing is, the surface, as Sajjad said, is very broad. Now, the question is also the specialization. Previously, we used to talk as a SREs, specialized engineers who could be domain experts in a particular thing, right? But here, the domain is vast. In the sense, if you really see, There's so many areas to cover, right? From Kubernetes to GPUs to networking. So in fact, if you look at it, this is wholly looking like a layer 1 to layer 7 for AI, actually, right? And so you need specialization at every level, at the chip level, at the GPU driver level. You need optimizations at the PyTorch level, where custom kernels need to be written. Then you have above that the different applications you're building, and then on top of it, you have the agentic stuff. That's a different domain which is growing like anything, actually, and multi-agent communication. So this is not something that you could just say, okay, this is the diameter of this whole thing, and I could shrink it to this. It's a vast space, and then again, you need the continuous thing. Day 0, day 1, and day 2. You need to go through the whole cycle. And again, as Satya brilliantly put it, it's based on those experiences. You go refine it further and further and further. So the role of the forward deployment engineer becomes very critical because they understand the systems. Normally, even in typical systems, if you are with a customer, you wouldn't be forced to leave the account because you have so much experience with that customer which you have developed over the years. Now think about somebody who is optimizing that stack for that customer, and in that role they're doing it for quite some time. They become invaluable because they know all the metrics, all the stuff that goes into the customer's AI establishment itself, right?
Okay. So Sam, I think we've run out of time. So I really appreciate Satya, our special guest. Maybe I should say, like the TV show, special guest star this week to joining. I think it was a great conversation, and thank you so much again, Satya. Talk to you guys later.
Thank you, Sunil. Nice being here again.
Thank you, guys.